What we're going to be looking at today is a little example of using Einstein's equation in a problem. So here's an example problem. We've got a photon of energy, 2.4 electron volts, strikes a surface that has a work function phi of 1.6 electron volts. And they want us to find the maximum speed of the emitted photoelectron. Okay, well, immediately when I read this question, I know that my photon energy is greater than the work function. So I know that a photoelectron is going to be emitted. If it's below that, nothing's going to happen. But good, we're in business so far. I've written down here Einstein's equation. HF, the photon energy, is equal to phi plus K max. Now, typical confusion is to try and think, well, I'm not given the frequency, but remember, HF is the energy of the electron. So the question has almost skipped a step because they've not given us the frequency, they've just given us the energy of the photon directly. Okay, well, we know this is 2.4 electron volts. We know that phi is 1.6 electron volts, which means that we can deduce our maximum kinetic energy, or K max, is then simply 2.4 minus 1.6, which is going to give us 0.8 electron volts. Now, depending on the units that I'm interested in, I will definitely, if I want my answer to be in meters per second, I want to convert that to joules. And remember, if I can see this E over here, that means I need to multiply by the electron charge to convert from 0.8 electron volts to joules. So this will simply then be equal to 0.8 times 1.6 multiplied by 10 to the power of minus 19, and if I put that into a calculator, I should get 1.28. See if my marker is working. Yeah, 1.28 multiplied by 10 to the power of minus 19 joules. Okay, now I'm in business. I've got my kinetic energy, so all I need to do really is use a half mv squared and rearrange for my final velocity. So, shall we do that? Let's just say that K max, so we can just say Ke max is equal to a half mv squared. Rearranging for V, that's going to be 2 times Ke max divided by m, and because it's v squared, I need to square root this whole expression, so we need to do that. And if I plug in all the numbers over here, so it's going to be 2 multiplied by my maximum kinetic energy is 1.28 times 10 to the power of minus 19. And my mass of an electron, which is given in your formula booklet, is 9.11 times 10 to the power of minus 31. And if you input all these numbers into one of those scientific calculators, we should get that the speed of the electron is 5.3 multiplied by 10 to the 5 meters per second. Okay. So, typical mistakes include just a little bit of confusion with that equation. Remember, if you're given the wavelength, rather than HF, you should just use HC over lambda, because that will also give you the photon energy. If you're given just the energy, such as in this case, we can just plug that in directly. If you're given the frequency, we need to multiply that by Planck's constant to get the photon energy. Good. So, just to recap, we've used Einstein's equation, we found our kinetic energy, we converted that to joules, and then straight after that we used